10 years ago, I started my first job as a backend engineer. I thought I knew what I was getting into. I've done the tutorials, I built the projects, and I passed interviews. However, I was wrong about almost everything. Nobody told me that my best work would go completely unnoticed, and nobody prepared me for that constant feeling that I'm falling behind. Today, I'm going to tell you 7 more things I wish someone had told me before I became a backend engineer. Some of these things might save you, as one of them almost made me quit backend engineering entirely. By the end of this video, you'll know exactly what backend engineering looks like. Not the fantasy version, the real version. So let's get into it, starting with thing number 1. Your best work as a backend engineer will be completely invisible. And I don't mean invisible in some philosophical way. I mean, literally nobody will see it or know what you did. Let me tell you what happened in my first year as a backend engineer. I was working on an e-commerce site. The checkout system was really slow, painfully slow. Customers were complaining all the time. Some were even abandoning their carts because it was taking too long to load. I spent some time investigating. I found the problem. We were making way too many calls to the database during checkout. Every time someone tried to check out, the system was making 50 separate database queries. It was absolutely ridiculous what we were doing. I fixed it, got it down to just 5 queries. Checkout went from taking 12 seconds to taking around 2 seconds. And with that, the cart abandonment dropped. I was proud of this. This was real impact. I thought for sure people would notice and give high fives all around. Performance time came around and my manager gave me feedback. Want to know what he said about my checkout optimization? He said nothing. He literally didn't mention it at all. And it was because he didn't even know I did it. Nobody knew except for me and maybe one other senior engineer on my team who reviewed my PR. He knew I did the ticket, but he didn't know how much effort and complexity or business savings that came from it. This is what being a backend engineer is actually like. When you make things faster, nobody notices because they expect things to be fast. When you prevent crashes, nobody knows because the crash never happened. When you optimize costs, nobody sees it because they never see the cloud bill. Your work happens behind the scenes in databases and APIs and servers, things that people don't typically look at. If you compare that to the front end, a front engineer builds a new feature and everyone can see it. Everyone can click on it, use it, share screenshots of it. But you make the invisible stuff work. And when it works well, people just assume it's supposed to work that way. Here's what makes this even harder. When things go wrong, suddenly everyone knows it's a backend error. Site goes down, backend engineer's fault. API is slow, backend engineer's fault. Data is somehow corrupted, backend engineer's fault. We have security issues, backend engineer's fault. So you get blamed for when things break, but you don't really get too much credit when things work well. This was honestly probably the hardest thing for me to accept in my first year of coding. I kept thinking, why doesn't anyone notice the thing that I'm working on? It felt like you were the black sheep of the team. And the answer is, it's because you're not being vocal or telling them about what you're doing. See, I was describing my work in technical terms. I was saying I optimized the database queries or I refactored the authentication service. Nobody understood what that meant, or they might have not even cared. But when I started translating my work into business impact, things changed. Instead of saying I optimized the checkout, I started saying I fixed the slow checkout problem that was causing customers to abandon their carts. Based on our data, this should reduce cart abandonment by 20%, which is roughly $30,000 more revenue per month. That is literally the same work, but completely different story. Now people understood. Now people cared. Now people remembered what I did because there was some kind of dollar or some kind of measurable attachment to the work. So here's what you need to know going in. Your technical work will be invisible unless you make it visible. And making it visible means explaining it in terms that non-technical people can understand. That's part of the job in itself. Not, I improved the API response by 80%, but I fixed the problem that was making our mobile app feel slow, which should improve our app store ratings, and reduce the number of customers who uninstall. This is a skill that you don't learn in tutorials or boot camps, but it's crucial for your career. Keep a brag list where you track every significant thing you do and the business impact it had. Every few months, share it with a manager. Not as bragging hey, an ego boost, but as a way to literally show what you've contributed. Because if you don't tell people what you did, they won't know. And if they don't know, you won't get credit. And if you don't get credit, you won't get promoted or probably enjoy this career because everyone kind of likes a good pat on their back every once in a while. So welcome to Backend Engineering. Your best work is invisible Learn how you can make it visible. Thing 2, the one place you should always look first. Okay, so here's something that I wish someone told me. When something goes wrong in your backend system, I would always start with the database. And I mean this literally, not sometimes, not occasionally. Almost always start with the database because the database is probably what's failing. Let me tell you about my embarrassing moment as a backend engineer. I was about 6 months into my first job. We were launching a new feature, nothing crazy complicated. Users could see a list of their previous orders, a simple feature, and I tested it locally. It worked perfectly, and I deployed it that afternoon. Big mistake. That evening, I was getting messages that the site was slow, really slow. Some pages weren't loading at all. I logged in to check all the metrics, and the whole site was basically frozen. I panicked big time. Started looking at everything. Maybe it's the server, maybe it's the network, maybe it's some kind of weird caching issue. My senior engineer at the time looked at one thing, the database. He pulled up the database monitoring tool and immediately saw the problem. Our new feature was killing the database. Here's what happened. When I tested locally, I had 10 test orders in my database. So when I queried for a user's order history, it happened. No problem. It worked. But in production, we had millions of orders, and my query was reading through all of them, every single order in my entire database. Not for every user, but just for the user that was logged in, but it had to happen on every page that was loaded. The database was trying to scan through millions of rows just to show someone their 10 orders because I forgot to add an index. One missing index brought down my entire site and was freezing everything. We had to do an emergency rollback, but it probably cost the company, I don't know, we were making a lot of money. So maybe $15,000 in lost sales for those few hours the site was down, all because of the database, which is the source of truth. And this wasn't a one-time thing, right? Looking back at my 10 years as a backend engineer, probably 80% of production issues I dealt with were database problems. Site is slow, probably database queries are taking too long. Site crashed, maybe you ran out of database connections. API timeouts, maybe the database is locked or waiting on another query. The high cloud costs, database might be using too much CPU, or you have inefficient queries, or you're logging too much stuff. The database is often the problem. And here's why this happens. Because when you're learning backend engineering, databases seem simple. You learn SQL, you learn how to insert data, maybe select data, delete data, update data. You build your little project and it works fine. Everyone focuses on code, but production databases are nothing like that. Production databases have millions, in some cases billions of rows of data. Hundreds of queries happening at the same time, complex relations between all the tables, indexes that need to be added and maintained, connection pooling that can get exhausted. There's also something called locks that can cause deadlocks, and backups running in the background, and replication lag between primary and replicates. There's a lot of stuff going on. And all of this complexity is invisible until something breaks or you need to fix it. And when it breaks badly. A slow database query doesn't just affect one query, it affects everything, because while that slow query is running, it's using up database resources. Other queries have to wait. Those queries time out. Users see error pages, and then that's when the alarms start going off. Let me give you 2 of the most common database problems I've seen. The first one is missing indexes. That is the story I just shared. This is one that everyone gets. You write a query that searches for something, it works fine for 100 rows, but then when you have 1,000,000 rows, all of a sudden all the queries take minutes to run. Why? Because without the index, the database has to read every single row to find out what you're looking for. Now, the second one is called the N+1 queries. This is when you accidentally make way too many database queries. You get a list of 100 users, then for each user, you make another query to get their data. That's 101 queries. But what you could have done is just done all of that in 2 queries by using joins and the right selections. So when you have thousands of users, this kills your database. And here's what's really scary about database problems. They're hard and very expensive to fix. You can't just restart the database or refactor a piece of code. Databases have state, they have data, and database problems scale very badly. A problem that affects 100 users might be annoying. The same problem with 10,000 users brings down your entire system. So here's what you need to know going in. Learn databases. Really learn them. Not just how to write SQL, learn how databases actually work. Learn what indexes do. Learn how to, execute a query plan. Because I promise you, the database will be a problem. And when it is, you need to know how to fix it fast. Every backend engineer I know who's really good, they're good at the database. The ones who struggle, usually it's because they never took databases seriously. So don't be like me. Don't learn this lesson the hard way. Thing 3, the surprising time ratio. All right, here's the thing about number 3. And this one surprised me more than anything else when I started and became even more relevant due to AI. You'll spend way more time reading code than writing code. Before I became a backend engineer, I thought the job was all about building new things. Writing new features, creating new APIs, solving new problems. That's not what the job is, though. Let me tell you about my first month it was my second job. I joined a company with an existing product. The code base was about 5 years old, hundreds of thousands of lines of code probably. Multiple engineers have worked on it over the years. And my first task was to add a simple feature. Just add a new field to the user profile that could be updated through an API. And that seemed simple enough, right? With that, I barely wrote any new code. Want to know what I spent most of my time doing? Reading code. Trying to understand how the existing system worked. I needed to figure out, where the users are coming from and how they're stored, how the authentication system worked, where the profile updates were being handled, what validation rules existed, how data was sent back to the front end. Every question led me to more code to read. I'd open one file and find that one file called multiple functions, and then open up those files and see multiple other imports. Before I knew it, I probably had 30 files open trying to understand one simple flow. In the code, it wasn't clean tutorial code that you're taught. It was real production code written by different people with different styles. Some parts made sense, other parts were super confusing. And then there was these random parts that just felt completely wrong. I remember thinking, why is this taking me so long? I know how to code. This should be easy, but that's not how real backend engineering works. In tutorials and school projects, you write code from scratch. You make all the decisions. You understand everything because you wrote it. The code is clean because you just wrote the code that was clean, or you're following clean code because people aren't usually doing horrible code in tutorials. In a real job, you're working on someone else's code base, or a code base written by 10 different people over multiple years. You didn't make the architecture decisions. You don't know why things were done a certain way. The original engineer who wrote it probably doesn't even work at the company anymore. So you have to read. You have to read a lot. You read code to understand how things work. You read code to figure out how to add your feature. You read code to understand what might break if you change something. If an AI writes code, you read that as well. You read code to figure out why something is even broken in the first place by debugging. And that's why it shocked me the most. Even when I was writing new code, I always spent more time reading it. I'd write a function that I need to call it somewhere else, so I'd read code to find where it should be called. Then I would need to handle errors, so I'd read code to see how errors were handled elsewhere. Then I'd need to add tests, so I'd test existing tests to understand the testing patterns. For every 10 lines of new code, I probably had to read 100 lines of existing code. And like I mentioned earlier, AI is not changing this. If anything, AI is making the read to write ratio even higher because code bases are going to grow. They're going to get more complex, more interconnected, more things that you're gonna just have to understand. And here's what makes this really hard. Nobody teaches you really how to read code or read other people's code. So in school and boot camps, you learn how to write code, you practice writing, you might get feedback on your writing, you might read your own writing. But reading code, that's a completely different skill. And it's honestly harder. It's easier for simple things, but it's harder for big features and complex things. Writing code is creative. You're building something new. Reading code is, the closest thing is detective work or, reading a novel. You're trying to understand how someone else was thinking, why they made certain decisions, and what assumptions they made. Sometimes the code is just bad and you have to push through it. Sometimes it's good. Just make sure that you're always reading code and practicing like it's a skill. Now, thing 4, what actually matters more than excellence. Now, this one was really hard for me to accept. Perfect code doesn't matter. Shipping does. When you're learning to code, you're taught to write good code, clean code, well-structured code, code that follows best practices, code that's elegant and efficient. And that's great for learning. However, perfect code is often the enemy of getting things done. I was about a year into my career. My manager asked me to build a new API for a feature the product team wanted. They needed it in 3 weeks. I was excited. This was my chance to show what I could do. I was going to build this perfectly. I started designing the perfect architecture. I had the best practices. I created all the diagrams. I planned how everything would be structured. I was going to build this the right way. Then I started coding and I rewrote things. I rewrote things a lot because I wanted everything to be perfect. Every time I finished something, I would look at it and think, I probably can make this better. So I'd refactor it. Then I'd refactor it again. What I was missing was the good old good enough versus perfect code debate, because now I'm a huge believer in good enough code. But every time I say this, I always get someone out there criticizing. So let me make this super clear. Good enough code is not the same as poor code or bad code, right? Good enough code is when it works correctly for the current requirements. Can it be understood and modified by other engineers? Does it have proper error handling? Does it have tests for the main functionality? And does it ship on time? Perfect code follows those same principles, but it changes a little bit, right? Like it handles every possible edge case imaginable, is optimized for performance that you don't need, has 100% test coverage, uses the absolute best architecture in patterns, takes 3 times as long to build. Here's the mindset shift you need to make. Your job isn't to write perfect code. Your job is to solve business problems with code that works and can be maintained. Ship it. Get it in production. Let real users use it. Then learn what actually matters and what doesn't. Then improve it if needed. I did not say put it in production for users to test and break. I'm saying put it in production for the users that need a new feature to be able to use it right now. This is really hard if you're a perfectionist. And a lot of people who become engineers are perfectionists, but you have to let go of this perfection mindset. Done is better than perfect. Shipped is better than polished. And working is better than elegant. You'll rewrite most of your code anyway, probably, either because requirements change or you learn better approaches in the future or the business pivots or technology evolves. So stop trying to make it perfect. Make it work, ship it, move on to the next thing. That's what backend engineering is actually about. Not writing perfect code, but shipping solutions fast. Thing 5, the skill that makes or breaks you. Okay, thing number 5, and this one really shocked me. Writing code is actually the easy part of being a backend engineer. The hard part is everything else. When I was learning backend engineering, I thought the job was basically write code, deploy the code, done. Nope. I was working for this company for about 6 months. I understood the code base pretty well. I was tasked with building our reporting feature. I knew exactly how to build it. Like this wasn't like something I had to investigate. The technical part was very straightforward. I built it. Took me, I don't know, like a week or two. Wrote good code, tested it. It worked perfectly. Then I deployed it to our dev environment. The product manager immediately messaged me. This isn't what we asked for. I was confused. I'd built exactly what was in the requirements doc. Turns out the requirements doc was wrong. Or more accurately, the requirements doc said one thing, but the product team actually needed something different. I should have asked more questions. I should have shown more demos along the way. I should have made sure I understood what they actually wanted. But I was so focused on the technical part, writing the code, that I forgot about the communication part. So I had to rebuild it. That's when I learned writing code is the easy part. Understanding what to build is the hard part. And it's not just understanding requirements. It's everything around the code. Let me give you some real examples of what actually takes more time than just simply writing code. So throughout your day, you might need to be explaining your technical decisions. You can't just make decisions and build things. You need to explain why you're doing it this way. Maybe that's by writing design documents or presenting to your team. You need to be able to get buy-in from other engineers, address questions, and answer concerns. 2, code reviews. Every piece of code you write needs to be reviewed by other engineers. They'll have questions, they'll suggest changes, you'll need to explain your approach. You'll have to discuss trade-offs, sometimes defend your decisions, sometimes completely rewrite things based on feedback. I've had code reviews that took longer than writing the original code. 3rd, meetings. The meetings. Planning meetings, stand-up meetings, design review meetings, cross-team meetings, product meetings, architecture meetings. You'll spend probably quite a lot of hours a week in meetings, not writing code, not even really talking about code. And then you need to be able to debug other people's problems. The front end team can't get your API to work. You need to spend some time helping them figure out that maybe they're sending the wrong data or they're, trying to consume the wrong data. The data science team might need access to some data. You might spend an hour explaining some data to them. Maybe another team service in the company is calling your service incorrectly. So you spend some time helping with them. All of this takes time. None of it is writing new code. And the engineers who succeed, they're good at all the other stuff, right? Not just writing code, but all the other stuff. They communicate well. They explain things in ways that non-technical people may be able to understand. They help other teams effectively. The engineers who struggle, on the other hand, usually it's not because they're bad at coding. It's because they're bad at communication. So if you're thinking about becoming a backend engineer, know this. Improve your communication skills. Practice explaining technical concepts simply. Learn to write clearly. Get comfortable presenting ideas. Because for most people, this is the hard part. Now, thing 6 is the invisible responsibility. Now, here's the thing about number 6, and this changed how I think about my work entirely. When you're a backend engineer, you're building for all the people you've never met yet. And you need to care about those people even though you'll never see them. Let me explain what I mean. I always thought my job was to build back-end solutions like APIs, databases, and make them work well. If the API returned the right data, my job was done. That's it. I didn't think too much about who was actually using these APIs on the other end or why they even needed them. Then something happened that changed my entire perspective. A customer tried to purchase something on our website 5 times, and it failed every time. They were frustrated and angry and eventually gave up. I looked at the logs and I found the issue. My API was rejecting the customer's payment because of a validation rule I've added. The customer's address had a PO, like a PO box unit number that was longer than I'd allowed in the validation. It was a simple fix. I just had to change the validation to include a couple more characters. So I deployed it like the next day, done. But then I remember my manager saying something that kind of like stuck with me. And it was simply that customer was trying to buy something important to them. Maybe it was a gift for someone, maybe something they really needed. And our system stopped them from being able to do that because of a technical decision I made about field length. And that kind of hit me hard, right? It wasn't just code. It was someone's experience. Someone was trying to do something and I was either helping them or stopping them from being able to complete something. Like that customer wasn't a data object. They were a real person wanting to buy something and got frustrated from our system. And they'll never know that it was because of a decision I made about how long an address field should be. This is what backend engineering actually is. You're building systems that affect real people, but you never will see those real people. You never get to talk to them. You just see data and requests and responses. And luckily, my mistake wasn't like a healthcare system, but I did waste someone's time. Technology is supposed to improve lives, not waste time and waste lives. And that makes it really easy to forget that, there's humans on the other end using our technical solutions. So here's what you need to know about this. Like, you're not just a backend engineer, right? You're building something who's building systems that affects real people's lives. Even if you never get to see those people, you need to be able to take that responsibility seriously and care about the other people using your work. So to do that properly, you need to think about their experience, not just like technical correctness. Because at the end of the day, your job isn't just to write good code. Your job is to help people do things they want to do. And the code is just a tool to be able to achieve that. Now, number 7 is the treadmill that never stops. All right, here's the last thing. And it's honestly probably the hardest and best thing for me. As a backend engineer, you're going to always be learning, not because you want to, but because you have to. Because if you stop learning, you will become obsolete. Let me tell you how I learned this. I spent time getting pretty good at Node.js. I was using the Nest.js framework for a project I was on. I knew it pretty well. I knew like all the best practices, all the common patterns. I felt really confident using it. Then a bit later on, everyone started talking about serverless. Traditional backend is dead, people said, right? Everything should be serverless functions now. And I was back to learning again. AWS Lambdas, cloud functions, how to think about serverless architecture, completely different than what I was doing before. And that has swapped a couple different times. Like now it's all about AI integration. So you're going to hear a lot of things about Python and Fast API. The learning never stops. And if you're not someone who loves learning, this can be really exhausting. And here's the reality of being a backend engineer this year. The technology is changing constantly. There's so much changing right now. If you weren't doing microservices, you were falling behind or your team wasn't technical enough, and people were always trying to sell you on microservices. Now, people are saying, screw microservices, keep it monolith as long as possible. And some companies are even combining their microservices back into monolithic. It's like literally the trend reversed. There was also GraphQL, which is going to replace all of the RESTful endpoints. Everyone needed to learn GraphQL. Then people realized GraphQL added complexity and didn't have all the pros and cons it was talking about as like it was before. So now people are switching back to REST. No SQL databases were going to replace relational databases. SQL is dead. You could hear that all the time. But then companies started realizing that they actually wanted relational database and transactions. Now everyone's using PostgreSQL again, or Oracle database, or MySQL, SQL Server. What I'm trying to say is that learning never stops. Right? You're always going to be learning new technology. And the best way to learn is to actually build things with it. That takes time. Time you probably don't have working full time. So you need to genuinely enjoy using these technologies. So you're probably going to spend some time at nights, maybe on the weekends, whenever you can find time. And while you're learning the new thing, something else will come out. Like the treadmill never stops. You need to be okay with being a constant learner, not just okay with it. You need to actually enjoy learning because you're going to be doing it for the rest of your entire career. This just means you're okay with feeling like you might be a beginner again. Maybe not all the way back to like when you first started learning backend engineering, but there's going to be a lot of things that you need to learn. Like no matter how many years of experience you have right now, if you're trying to dive into AI and you want to learn about RAG and AI agents and large language models and all these different coding assistants, you're going to be relearning. It's literally nonstop. So you're just going to be able to accept that you're going to sometimes be behind some of the technology trends and that you always need to be learning. The best thing you can do if you're brand new is get really strong fundamentals. I truly believe that fundamentals are irreplaceable. They kind of follow you with all your frameworks, all your tools, no matter what direction you go. So it helps you tremendously when picking up new languages, new tools, new frameworks. You need to make sure that you are fundamentally strong. When you're fundamentally strong, you can use AI, you can do a lot of things and still be able to produce really good results. The ones who struggle are the ones who want stability, who want to master only one technology and maybe not the fundamentals that go with it. That doesn't work in backend engineering anymore. You need to be diverse. You need to be able to work with a bunch of different things. So if you want to become a backend engineer, you need to know this. You're signing up for a career of constant learning. The learning never stops. The technology keeps changing and you need to be adaptable and be able to change with it. That's the price for admission. For some people, that's exciting. For others, it's terrifying. Figure out which one you are before you commit to this career. All right. Hope you enjoyed the video and I'll see you in the next.